last time we covered 3 different ways NAT could help a load balancer, right? We talked about dual NAT, server NAT, and transparent mode. And basically, one thing I discovered, basically after I went and thought about it a little bit, and I think this is important to realization, that these 3 modes really correspond to 3 selections, whether to change the IP, whether to change the port, whether to change both. So if a normal NAT does change both. It changes the IP address and the TCP port. Right? That's what the normal NAT does outside. So if you do both, that is called dual NAT. If you just change the IP port, that is called the server NAT. If you change none, that is called transparent. And that is the basic difference between the 3 modes. Eh? Yeah, one arm will come in a minute. So first thing we realize is that there are 3 varieties, and of course they have 1 1 0 1 0 and 0 0. There could be another one which is 1 0, which means just change the IP address, not change the port. I don't know why it is not there, but basically these 3 modes that are there correspond to these 3 combinations, which is really easy to understand and remember now, because dual has both on, and transparent has nothing on, and server has one side on, right? All right. So given that, now we go to the dual NAT. In the dual NAT, we change both the IP address as well as the source, so there is no problem. Everything will come to you regardless of what your address is, whether it is in the same subnet or different subnet. Your address is in the packet. It will come back to you. All right? Is that clear for the dual NAT? Then we go to server NAT. In the server NAT, only thing we change is the port number. Remember that one. Just the port number. We are not changing the IP address. And therefore, the server does not know where the packet came through. Right? The only way it will go back to the load balancer is if the load balancer is the default gateway. And the packets go to the default gateway only if they are going out of the network. If you are going inside the subnet, you don't go to the gateway. Is that clear, right? That explains your question, right? And so the only way to get back without knowing where it came through is to make that door the only door, which is the load balancer. That's the only gateway. That's the default gateway. And so people who are going out of the room, they'll have to go through that door, and the server load balancer will know that this packet is coming back and forth. But if you are just going inside the room, you're going to the same subnet, you don't go to the default gateway, and there is no way to get it back to the load balancer. All right? Now in the transparent mode, actually we don't change anything. And so again we have to make something so that it basically everything goes through that. Right? That means we close all the doors. There is no door. Right? It's a switch which everybody has to go through. Only single thing, which is actually, we cannot call it gateway because it's not at layer 3. It's at layer 2. It sits at layer 2, and all the packets go through that switch. Right? And so that is the only way it works in transparent mode. Now, so that should be clear that each of these methods have a problem. And so this one relies on the MAC address, etc. Now, they have alternate names. One ARM mode, and routed mode, and direct routing mode. Now, one ARM I have to think about that as to why it is called one ARM, because this is generally, there are other places where we use the word one ARM. One ARM is used when you have only one port. And there are many routers which have just one port. No, I mean, you don't have one port to come in, one port to get out. You just come in from the same port, get out of the same port. Those are called one-arm router. Okay? Here, I think there are 2 ports. All right? So I have to think as to why it is called one-arm mode. And I will find out and let you know later on, right? So that is that one. Routed mode, clearly, we are just changing the IP address. Sorry, we are changing the port numbers. Again, why it is called routed mode, we are changing just the port number. But I think the reason we could call it routed mode is because this is a default gateway. So we could call that routed mode. And this is called direct routing mode. Again, it's as good as transparent mode where, there is no routing whatsoever. So the names actually came from different companies, and I don't have explanation for why they call what they call. But the interesting thing is that you have just 3 possibilities. Change the IP address, change the port number, change both. Change none, change the port number, change both. All right? And that is the thing. and second thing we learned is that changing the IP address is a problem, because if you change the IP address, then the server doesn't know the actual sender. And the server needs to know in many applications who the actual sender is. So changing the IP address is not, basically it has that disadvantage. And not changing has the disadvantage that, how do you get it back through the same path? Okay, that's the key of all these 3 slides. Any question about that now? Other than naming? Yeah.
You see the dual NAT, it says the dual NAT.
Dual NAT, yeah.
I think it's on the 3rd line. It says to change the destination port, but in the pictures it changes the source port.
Yeah. Okay. Where does it say destination port?
The 3rd line.
Load balancers uses the port number to find the client address and forwards it to the client.
Second part.
Yeah, here. One more? Okay, let's change both the source and the destination addresses and the destination port numbers on the client request like a regular NAT.
But in the picture it changes the source port, I think.
Right. Okay, so I should rewrite this one. Actually, this is writing problem. Is that it changes both the source IP and source port and destination address, not the destination port. That's actually a typo. Typo means mistake. Somewhere we have to make a note of this and change it. No, just give me a blank piece of paper right here. Yeah, so the source port number. Good. By the way, there was another typo that we discussed last time. You had pointed out, Robin, was that about what is the right Ethernet type? Actually, both of them were wrong. They were not consistent, but both of them were wrong. The right one is E7, ends with E7. And so I had put C7. I couldn't read that E7 actually. It was, wherever I was reading it, it was so small that I thought it is C7. So that is actually E7. And other place I used something like C8 or E8 or something. So that 8 was wrong. But it doesn't matter because, I wouldn't ask you that. I wouldn't. See, thing is, I am asking you to fill in the blanks, but I'm really not asking you to memorize the numbers and things like that unless it is critical important. For example, it is important that you know OC3 runs at 155. Believe it or not. If you went to a meeting and you didn't know what OC3 is, then you don't know OC3. So I would ask you that, how much is OC3 running at? But what is the port type? I wouldn't remember 10 days from now, and I wouldn't ask you to remember that 10 days from now. But there's something that I remember, which we need to know. T1, does everybody remember where the T1 runs at? That you have to remember, memorize it, because that is, in everyday business, people know what T1 runs at. Speed. All right? But, so anyway, all right. So, it's like port 80. We don't remember other port numbers, but if you don't know port 80, then, what do you know? Right? So, things like that. There are something which are very common, and I want to make sure that you remember them. All right, I think we are done with the NATs business, and we go into load balancing for firewalls. All right, so now the firewall load balancing, as we discussed a minute ago, they need to know who is sending it, because firewalls don't want to really make a decision based upon the load balancer address that they are being bombarded. So clearly, you cannot you have to use particular load balancers that will not change the source address, and that leaves you with the last two. And the second thing is, you want the traffic to come back to the same firewall, because if the traffic went to some other firewall in the return type, then it would be a problem. So you need two load balancers. This one balances is based upon something, and this one balances is based upon something, same thing basically, so that while returning traffic, will go to the same firewall. So this one, for example, could do the destination port. Let's see. So this one could do source IP and source port, R port, and this one will, while coming back, this will be destination IP and destination port. Right? That way they will both select the same firewall for both directions of traffic. You understand the complication that we run into when we do firewall load balancing? Unlike a server load balancing, in firewalls you don't have a choice of using dual NAT. Right? And second thing is, you don't have a choice of going one way. And you got to go, return traffic also has to go there, because firewalls maintains the state, and that state will be, the firewalls will go crazy if the return traffic did not come through them, or if they see a traffic that they have not seen the forward part of it. That's the only key point on this slide. Is that clear? Right? That you need two load balancers, and they have to be programmed appropriately so that the traffic comes back to the same place. Yeah.
Firewall shares their information between.
The firewalls share the information between them? They could, but I mean, that would be a lot of work to do at the data plane. The thing is, the packet is going at 10 gigabits per second on each of the firewalls, and if they're changing and saying, oh, I got this packet, I saw this packet, it's too much. So I think the only thing they will share is the policy, not the data plane. Policy is control plane, is that they will have the same policy.
Because they should share the record. I mean, this IP address is send a lot of packets to firewall.
Right. So that will be caught anyway. By this method, it is caught, because that IP address will always go to the same firewall if they are using source IP address thing. If you are not using it, then all of them will see that DOS attack, denial of service attack. So yeah, but I mean all right. So the idea is, in the data plane, you don't want to really be doing like at the line speed sharing of information which is changing at the line speed. Okay, and so that is why you need this. Now there is something called reverse proxy. So we talked about proxy. Proxy, you put, every company puts proxy for the outgoing request. Okay, for example, Washu might have a proxy. All your Google requests are going to the proxy, Washu proxy, and not really going to Google. Okay, because if everybody is looking for the similar information, that information is already in the proxy, and so it can satisfy a large number and not have to spend money on the traffic going out, which costs money. So there are lots of proxies which are used by the enterprises to minimize their outgoing traffic, and so that is used for the clients, right, to save the traffic for the clients. So that is what is called proxy. But this is reverse proxy. Reverse proxy is for the servers. Okay, so this is for the incoming request, and so basically when the request comes in, it doesn't really reach the server, it goes to the reverse proxy and it gives the answer. So the same thing, proxies are caches, reverse proxies are caches, but they are serving the servers as opposed to serving the clients. If I take the same box and put it here in the client company, that would be called proxy. Everybody understands? Nolan, can you move forward this way, please? I can't see you. Any question about this? SSL offload. So SSL is secure socket layer, and another name for similar thing is TLS, transport layer security. So SSL was invented by Netscape when they wanted to and there was a time in 94 people didn't know how to do secure transactions. You couldn't buy things on the internet. So Netscape solved that problem by inventing SSL. Basically it encrypts all the messages between you and the server. And then IETF took over the job and designed a version of it which is a standard version called TLS. We teach all this in the network security course. And so whenever you put an S after a protocol that is a secure protocol, HTTPS or FTPS, they are basically using SSL. And all that means is that the data is encrypted, and so some load balancers provide SSL offload. So basically what happens is that SSL is nowadays required for many kind of applications. It is not required for search, but it is required for any banking transaction, any Amazon transactions, any buying, every place, right? So when you have so many servers which are doing SSL, you might as well offload that to something else, some other box, and they let the application do whatever they are supposed to do, right? The servers do. So we have SSL offload. So some balancers provide the SSL offload, and now the question is, where is the security? So first is, security could be only between the client and the load balancer because that is public internet, and there is no need for security between LB and server because that is private network. But it is quite possible that you cannot do that. In some cases you are running on the cloud, and maybe this part is already coming through IPsec or whatever. So this part needs to be secured because you don't want other clients on the cloud to see your traffic. So the offloaders could provide both. They could provide termination and initiation, but in this case they could provide termination alone or initiation alone. So that's all basically. And then the question is about the certificates. So basically, I don't know how many of you know certificate, but you probably have seen the certificate in your browser, right? Those certificates can verify that this message came from Amazon because there is a certificate in your browser, actually not from Amazon, but there is a certificate from the company that issued the certificate to Amazon. So Amazon sends you a message saying that, okay, here's from me. So how do you know this is from Amazon? Is because Amazon sends you their certificate, and then you verify that the certificate was issued by the company which says this was issued by me, generally VeriSign or something, and VeriSign certificate is in your browser built in. Again, all of this is in security class. But the idea is that if you have lots of client and one server, then each client will need a certificate, and when you go to a certificate company like VeriSign, they charge you, $20, $30 a certificate. So you don't want to pay that for 100 clients or 1,000 clients. You just use one certificate for the LB, and then this is encrypted. One certificate for all clients, saves cost. End-to-end SSL. So now you could do two SSLs, one here and one here. Okay? So that's a special consideration for SSL offload. Any question about this? Yeah.
What is the offload here?
Offload means, offload, let me explain what is offload means. Offload means basically the server doesn't have to do that job. So for example, if the clients are insecure, for example, you want to, suppose this is Amazon server and this is me, right? Now obviously if I'm buying something, this has to be secured, right? And the server has to do all this SSL work. And that is basically something, nothing to do with buying and selling, it is just SSL, anybody who knows SSL can do it. So the load balancer can do that. Right? So it has offloaded that work from the server.
So does that mean the link between load balancer and the server is not secure?
Not secure. So it has offloaded that work from the server into the load balancer. In the other side, SSL initiation, basically it has offloaded that work from the client. Okay? So offload basically means not doing in here but doing somewhere else. It's like, they do some jobs in India, not doing here, right? That is offloading. Many companies get things done in some other place. All right, TCP multiplexing. That's another thing that ADCs can do, and they do actually, is that clients have to set up TCP connections, and each TCP connection requires a three-way handshake. And we don't have to let servers do all of that work. The load balancer can do all of that work, and it will end the TCP connection right here and forward the request on a single TCP connection, which is with the server. Just one connection it has, and it keeps it for a year. Keeps it forever. Right? Now, so instead of n connections, now you have n plus 1 connections. So what is the advantage of this n plus 1 connections? Can anybody think of an advantage?
Redundancy in case of failures.
First of all, he says there is something in case of failure.
For the link you were saying, n plus 1?
No, there are not n plus 1 links. N plus 1 TCP connections. Of course, there are n plus 1 links even before, but now there are n plus 1 TCP connections. So the advantage is this, I will tell you what. It's when you know how the TCP works. So first of all, the way TCP works is, and now it's again 473, is that the window starts very small and then it goes up by slow start. Right? And so it takes quite some time before the window goes up to where you need it to be. Right? And so if there were n connections, then each of them will be very little, tiny, they will take long time. Here, this connection has been there for a year, so it is running already at 5,000, very high window. Alright, so this connection is very fast. Alright, if this thing is put near the client, which it is generally put, like in the carrier's box, then these connections are very short. This is a long connection, and it's happy because everything is fast on that side. And so it just helps out to aggregate lots of little connection into one big one. The key word here is that this connection runs at high window levels. Everybody understand what that means? It makes sense. What does it mean? High window level? If it doesn't, ask questions right now, because if you guys are not asking, I don't know whether it is making sense or not. But in TCP, the windows change, right? Everybody knows TCP, right? Okay. HTTP compression. So most HTTP responses are compressed to reduce the bandwidth usage, and load balancer can offer this service. So the server simply sends the response, and then and load balancer can zip it. So because of this, ADCs are used everywhere in the data center in a very large number. So you see this picture shows that you're coming from the internet and it goes first to the SSL offloader, then it goes to intrusion detection IDS, then it goes to firewalls, then it goes to some application level gateway, context and whatever the application context, content routers. Finally it reaches the server. Now, the number of requests coming in is so large that one SSL offloader cannot do. So you need multiple SSL offloaders, and therefore you need load balancer just before them. One IDS cannot do, so you need a load balancer in front of the IDS. One application firewall cannot do, so you need load balancer for the firewalls, and so on and so forth. So there are so many load balancers and so many ADCs. All right. In fact, the number of load balancers and these things is almost as much as the routers. I'm sure the number probably has gone up because the routers number is not going up, I suppose, but the ADC number is going up with time. All right. We also call them middle boxes. So the number of middle boxes is almost as much as the routers. Now, since everything is being virtualized, servers are virtualized, and load balancers help that, but basically these things have to be virtualized as well. The ADCs have to be virtualized as well. Load balancer has to be virtualized as well because traffic is so much that one ADC cannot handle it. We already saw that. And previously, when you went to a company like F5, you found you bought their load balancer. It was a big box, much bigger than your server, monolithic, because it has to handle several gigabits per second and so on and so forth, right? Now, when you go to the cloud, you cannot put that box anywhere because every client has this piece, that piece, that piece. Everybody has a virtual network. And so where do you put a big F5 load balancer? You cannot. So you have to put that into the software and you put into a VM, and every client has their own VMs running load balancers. All right. So there are two kinds of, first of all, first step that the ADC companies did was to have their own load balancer being virtualizable. So you could buy one big box from F5, but will act as 5 different virtual boxes inside it. So the first customer takes this piece, second customer takes this piece, third customer takes that piece, and so they will be separated just like VMs are separated. But this was still a big box. Okay. Then they said, let's forget the whole hardware thing and put it in the software. So now these balancers are software pieces which are put inside the server. You see, this is hypervisor, this is your server. Servers are themselves virtual machines. And here is the balancer, load balancer, which is itself a software piece. And companies like Cisco and F5, everybody is selling, and I'm sure VMware as well, is selling these software-based load balancers and things like that. Then we talked about different things. We talked about, compression. We talked about firewall, ADC, and we need each of them on the path. So the question is, if everything going to be in software, we might as well put them into one software and do a lot of things. So that brings us multifunction ADCs. So one ADC will do lots of stuff. And by doing all of that together, we could, for example, we could combine data compression, security, load balancing, and blah, 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 protocol optimization, like TCP optimization, everything into one software piece. And so that is happening. So nowadays they are selling ADCs which are not just single function ADCs anymore. All right. That brings us to the end of this part. And the 4 key points. First, that you know that the application delivery is complex. Inside the data center, the application delivery requires replication and partitioning. So we talked about replication means just making copies. Partitioning means dividing the application into pieces. Partitioning means dividing the pieces depending upon the application, depending upon the user, depending upon the network state, and so on and so forth. So depending upon different contexts, we can partition the application, and so we need these ADCs. And the load balancer was the first ADC. And so when they designed load balancer, they had to invent a lot of stuff, such as those dual NAT, server NAT, all those things. And now, we have other functions such as TCP multiplexing, proxy, and so on and so forth. And then we talked about different flavors of NATs which are used by ADCs. And nowadays ADCs are very common, but also they are virtual and software based and multifunction. Yeah.
Question on the slides.
Yeah.